Welcome back to my channel. This is the first video as a tutorial for SAS to create some kind of software as a service, and more specifically this one is about an overview introduction about how to do RAG, Retrieval-Augmented Generation for large language models, LLM, because it's a hot topic at the moment, and it's also a low entry barrier for creating something, some kind of startup company. The reason why we talk about RAG and LLMs is because large language models are limited with the knowledge that has been used by the company or organization that created them at that specific time. So if you want something more specific for a topic or more modern, you need to do something. Either you fine-tune the model, you kind of retrain partially of it, or you add something through RAG, like doing some kind of prompt engineering that looks like something like this. So we have the new information, the new dataset that is been like kind of encoded and embedded in a vector database. And when we run a query, first the query is going through retrieving some kind of where is in this embedding, and then it's creating a better prompt augmented with this given by what is being found in the vector database. And then at that point we queried a large language model without touching the large language model. So we can still do all these things using the online version of large language model. And this is my ideal architecture at the moment, because these things are changing on a weekly basis. So first of all, we have some kind of front-end layer which can be created by Bootstrap or React or other extension of Node.js that is interacting from HTTP to the API, which is then the API interacting with the model. The reason why we do this is because this is the front end, this is something like the back end, and the API is like the interaction between the two. It's like a servant that is getting some requests from someone who wants to eat in a restaurant, for example, and is bringing the order to the cook, and then the cook is cooking something, and then the API is bringing back the dish to the customer of the restaurant. It's something. There's this metaphor that has been running around for a while. In practice, it's not interacting directly with the large language model. It's first processing the query with another layer. I will use Haystack, because the fact that a large language model is essentially something that is able to predict the subsequent word. Is building on the statistical probability that one word is after the other one statistically. So if you give, for example, a sentence like artificial intelligence transforming is doing some kind of encoding, embedding, and then producing human. So it's giving you the most likely, according to the machine learning model, most likely word that is supposed to finish the sentence. It's not an entire chatbot, a large language model. You need something that is able to handle the chain of thoughts, and also that is kind of in charge of the overall natural language processing. Then we have some kind of vector database, which is the one that is where we do the encoding for the text generation, the embedding, and then at that point there is the interaction with Mistral. Mistral is one model I would like to use at the moment, because we can use some version of it which is on 7 billion parameters, which will be considered at the moment a medium small language model. It has been shown that even if it's just 7 billion parameters, it's kind of able to outperform larger language models that take more time, more space. And it's been shown actually to works very well. So it's more on how the knowledge has been encoded and how the dataset has been used, rather than the fact that you have a certain number of parameters. So since this thing is kind of might be overwhelming. If you are a full stack developer, probably you have some kind of ideas how to build this, but if it's the first time that you are seeing this stuff, might be overwhelming because there are so many things here that you have to handle. Then when you program it, there are code dependency, Python version, then this library, there are other dependency behind these things that might be really a lot to do at the first time. So I start with something simpler. There is a library called Chainlit, which is actually very nice because it's someone created this tool which is practically replacing most of these components in one, and is also simplified them. It's been very nice. So it's handling at the same time the front end and the communication directly to the language model. So there is all these things simplified for people. And I will start to the simplest version without using the RAG, just to see how we combine these two things. And then later we introduce Haystack for the processing the query and also doing some kind of embedding, which is inside Haystack. There is also a way to do some kind of vector storing. It's not advanced as if we use like something like Weaviate or Chroma or some other fancier, more specific vector database, but it's already able to do that. But without even going there, let's do simply launching an application with just using these two components, Chainlit and Mistral. Obviously, we have two ways of handling this. First of all, I'm assuming we are working on these things on a local machine. And if you have a Python, you need to, first of all, get these two requirements. I know it looks ridiculous, but that's actually, because generally you have like 10 or 15 requirements. Now you have only 2. That's also showing you how easy this thing is. And this is how will look like a simple application. So you need to import just these two libraries. This import OS is simply because I'm loading the API key for Hugging Face, and it needs to get this file from my system. That's all. And then with the main for this looks like this. So I have 2 versions of this. One is related to if we want to use fully locally. So this means that the first time you launch this thing is going to download Mistral, and that's why you still need the token, because even to download you is probably going to ask you the API. And I'm setting also what it's going to use, if it's going to use the CPU or the GPU. And this is just how I'm going to handle asynchronously. Asynchrony means that it's not running sequentially, because, for example, if we were going to have an HTML page that is just waiting until you ask a question, and then when you ask a question, at the moment you ask the question, is performing this part. It's not going sequentially, just waiting for your action. And then it's simply collecting your prompt and sending it. So everything is managed by this cl.message, a function from Chainlit. And then the same one is getting the answer and is then sending it back. Now, if you want to use an even simpler version that I'm going to use now, or maybe because you don't want to download locally, the language model from Mistral, because it's still like 10-15 gigabytes. There is this way. In this way, we are going to simply connect to the endpoint model online through Mistral, do the question and get the answer, and plot it. And if you see the Chainlit front end, it will look like it's an independent application. So definitely now we need the token, because now it's going to use the token you have available. And when you finish the free ones, they're going to charge you. So be careful, because you're substantially using their machine. The difference that in one way, so if you download the model, the electricity is of the machine, the usage of the fixed costs are on you. In this way, the model is on their machine, so you're using their machine, so you're supposed to pay for their services. And yeah, once again, we have today we need to define the query and to pass again with this function message to send it and get the answer. So we, in fact, you see, you get I send the prompt, I query it, query the model, I get the result. Here I'm simply separating query and result, prompt and result, because it's used to send you both. And then at this point I simply put it in content and it will show me on the HTML the answer. Let's see how it looks like. The difference is also that I don't run it using Python. So I run it using their own command, which is chainlit run and the name of the Python script. At the moment it's configured to point to the localhost with the port 8000, and it will look like something like this. The idea is also that there is a folder where you can kind of add some customization. In fact, normally when you launch it, it's not looking like this. They have their own logo, and also there is other things at the bottom, like powered by Chainlit. Why I kind of replaced their logo with my logo. Then you can customize the title or other message, then you can change it. So let's try with something easy, like for example asking 2 + 2. Ta-da! And then I continue. Who is the current president of the USA? And it's telling me correctly Joe Biden. Now, the thing is that in the this is all running in my local machine. So I'm querying Mistral. The front end is on my computer, so it's not fully up. Also, because if you want to make a full SAS, you need something a bit more than that. Like you need an authentication, a way of payment, handling users. This is just really the beginning. But as you can see, I practically loaded an entire application with how many lines of code? On 42 lines of code, so that's really nothing. And apart that is not really an SAS, it's we are still at this level. So in the next video I will try to go a bit further, adding some NPL orchestration and also some vector embedding for the RAG, because at the moment this is not RAG, this is just using the model as it is, with the knowledge that they have. So we haven't done yet what I promised. I will do that in the next video, but if assuming you are already happy with this is already an application that it's on my localhost. So you need, apart that you need the overall the other parts of the SAS, you need to deploy it either on some kind of web services like Amazon Web Service or something else, or you need to have a physical machine which is accessible. In other way, you're not finished. So because this thing is only running on my localhost. This is for everything for now, and let's see on the next video when we proceed to the further steps.